everybody, we're going to talk about section 6 today. This is the last section in our chapter, and we're going to talk about how we can solve rational equations using all of the strategies that we've been learning up to this point. So today we're going to learn and remember how to use addition, subtraction, multiplication, and division of rational equations to solve them. And then later, we're going to find how long it will take for a friend to complete a job using what we know about rational equations. So let's jump right in. Here we go. We're going to solve this rational equation here, and we're going to solve, of course, for x. So first things first, I know when I see this equal sign, this is an equation. That means both sides of the equal sign are equal to each other, and we're going to cross multiply. Now you may have seen this before when we were talking about something with proportions. And cross multiplying just means that we take the top of the left side and we multiply it by the bottom of the right side. We're going to write it right here, and we go 3 times 4x plus 5 will go there. And then we're going to take the top of the left side and multiply it by the bottom of the left side, and put it right here. So 9 times x plus 1. And we're going to set up our equation that way. Now we're going to distribute. So if I've got this all written out, I'm just going to distribute. Okay, so we're going to distribute the 9 times x and the 9 times the 1, 3 times 4x, and 3 times 5. And now we're going to solve for x. We want to get the x's on the same side, so I'm going to minus the 9x over. We get 9 equals 3x plus 15. Subtract the 15 to the other side, and we end up with negative 6 equals 3x. I'm going to move this right here because I'm running out of room. And then we're going to divide both sides by 3, and we end up with x equals negative 2. All right, let's move on to the next one. So this one, we've got 2 fractions on the left side and 1 fraction on the right. So we can see here, in order to solve for both sides, first I have to combine this into one big fraction, which means I'm going to need to add these fractions, which we did the last class. When we add fractions, we have to have a common denominator. Here I see x and 4. They're not common. So I know that the common denominator that x and 4 can both become is basically multiplying to each other, which is 4x. So I'm going to multiply both sides by what they need to get to a 4x. So if I multiply both sides on the left here by 4, this denominator will now be 4x. And if I multiply the right side by x on the top and the bottom, the denominator will now be 4x as well. So I'm left with 4 times 5 is 20 in the top here. 7 times x is what we get. And if I combine these to one fraction, 20 plus 7x equals negative 9 over x. So now, in order to solve for this, I'm going to cross multiply again because we have the equal sign. I know I can cross multiply. So I'm going to multiply 20 times 7x times the x, and we're going to put it right here. Okay. And then we're going to multiply the negative 9x times the 4x, and we're going to put it right here. And then equal sign still stays in the middle. Now let's go ahead and distribute. So we go negative 36x on this side. Distribute the x to both of these, 20x plus 7x squared. So now we're going to solve, but remember, this is an x squared, so we're going to solve the quadratic, which means we need to get everything over to the same side so that it's equal to 0. So we end up with 7x squared plus 36x plus 20x. Well, let's combine like terms. We get 7x squared plus 56x equals 0. We can factor this down and pull out an x. We end up with 7x plus 56 equals 0. Now remember, when I've got two factors, equal each other, or times 0 equals to 0, we set each factor equal to 0. So x can equal 0, and 7x plus 56 can also equal to 0. So we're going to solve for 0. That's it. Subtract the 56. And then divide the 7. All right, so this is what we get. Now, we want to go back and make sure before we finish that both of these are going to work. So if I plug them back into the original equation, which we have up here, so again, remember, we've got -8 and 0. If I plug them back into the original equation, which we can, we can say that it's this one. It's one of the original ones. If I plugged in x was 0 to here and here, wouldn't I end up with this 20 over 0 plus 0 over 0? Can I have anything over 0? No, this is undefined. So here we know that x equals 0 is actually not going to work for us. So this is called an extraneous solution, which we learned an extraneous solution means it comes from the original problem, but when you plug it back in, it doesn't work out. So our only solution is going to be -8. All right, let's go over to this one. So here's our next problem. We see 1 minus a fraction equals 3x. So again, we're going to need to simplify this left side and make it one fraction by itself. So I'm going to write 1 as 1 over 1. And what that reminds me is that it is a fraction, that we can get the denominator to be the same as x minus 5. So I'm going to multiply both the top and the bottom by x minus 5. So this is going to give me x minus 5 minus 8 all over x minus 5, because once you've got that common denominator, we keep the denominator and we do the operation on the top. Bring down the 3 over x. And now we're just going to simplify what we see up here. So x minus 5 minus x gives me x minus 13. And now we can use the cross multiplication method to solve this proportion. So 3 times x minus 5 equals x minus 13 times x. And we're going to distribute those on both sides. And we get 3x minus 15 equals x squared minus 13x. So now again, we're going to solve for x, but remember this is a quadratic. So we need to get everything on the same side so that we can set it equal to 0. So subtract the 3x and add the 15. We get 0 equals x squared minus 16x plus 15. Okay, in order to solve this now, I see I'm going to have to factor this. And there's 3 terms, there's no GCF, so we're going to have to use x factoring. So we have to figure out what multiplies to 15 and adds to negative 16. So what are those two numbers? Well, I know the only way to multiply to 15 and add to negative 16 is a negative 15 and a negative 1. So this is going to factor to x minus 15 and x minus 1. Well, I know that when you have something times something equals 0, we use the zero product property and you set each of them equal to 0. So we've got x minus 15 equals 0 and x minus 1 equals 0. So I'm going to solve this now, subtract or add 15 to both sides, and I get x equals 15 here and x equals 1 here. Go back and make sure that it will work when you plug it back in. It works for both of these. So we can say for our answer, x can equal 15 and 1. Okay, so let's look at this. Okay, so we're going to work on this one where we see 2 fractions on one side, 1 on the left side. We also see that none of them are common denominators. They're super close, but not quite. So let's start off by factoring this one. We know it's going to factor down to x minus 3, x plus 3. Now let's compare that to the rest of our denominators. X minus 3, x plus 3, and this one's got both. So what we're going to do is we're going to multiply each of these to get a common denominator. I know this one on the right-hand side needs an x minus 3 in order to match this one, and this one's going to get an x plus 3. Now here's what's super cool about this. Do you see how all of these denominators are the same now? So x plus 3, x minus 3, x plus 3, x minus 3, x plus 3, x minus 3. If I were to multiply both sides by the denominator, that's going to cancel them out. So when we see if we see this equal sign and the same denominator, we can cancel all the denominators. So only if we see an equal sign and all of them have the same denominator. So I'm going to come in here, Fruit Ninja style, and we're going to cancel every single denominator, which this makes it so nice now. Because now we're just working with 6 times x plus 3 equals 8x squared minus 4x times x minus 3. So we're not even dealing with rational equations anymore. Now we can just look at this and we're going to distribute. 6x plus 18 equals 8x squared. And then just keep in mind this minus is on the 4x, so when we distribute it through, it's a minus 4x squared and a positive 12x. Let's combine like terms, and we end up with 4x squared plus 12x. And we're going to need to move everything to the same side because this is going to be a quadratic. So we're going to subtract the 18 to both sides as well. We end up with 0 equals 4x squared plus 6x minus 18. Let's pull out a GCF here. We can pull out a 2. We get 2x squared plus 3x minus 9. So if I'm going to factor this now, we've got 1, 2, 3 terms, and the a is not a 1, it's a 2. So we're actually going to have to multiply 2 times negative 9 is negative 18, and the 3 goes in the bottom. So what multiplies to negative 18 adds to 3? I know there's a 6 and a 3 that can work, and then we're going to split up that middle term. This becomes 6x minus 3 is x. We're going to bring down the minus 9 and bring down the 2x squared. And now we're going to group these. So we can pull out a 2x times x plus 3 and a negative 3 times x plus 3. So we're left with, these are twins, so we can pull out the x plus 3, and we're left with 2x minus 3 equals to 0. Solve that, and we get x equals negative 3. And if I go 0 equals 2x minus 3, we end up with 3 equals 2x, so x equals 3 over 2. And those are our two values. Go back and plug them back in. I can see in the original denominators, do you see how if x was negative 3, this would make it 0 here on every single one? So we know x equals negative 3 is an extraneous solution, so the only one that's going to work is this one. Okay.